Hi boys and girls, this is Chapter 11, Lesson 4. After today's lesson, you'll be able to find the mean absolute deviation of a group of data. I find that most sixth graders have never worked with mean absolute deviation before. It's really not that hard. The hardest thing about today's lesson is making calculator mistakes. You've got to be very careful. There's lots of numbers entering into your calculator, and if you make one mistake, it's going to be wrong. Okay, let's get started. The mean absolute, you know what the mean is from lesson 1. The mean is the same thing as the average. We're going to use the mean to find the mean absolute deviation. So the first thing we're going to write down is the mean absolute deviation, and I'll abbreviate that as MAD in today's notes. Mean absolute deviation. So the mean absolute deviation of a set of data is the average distance between each data value and the mean. So it's another way of looking at how spread out your data is. Just like the interquartile range and the range of your data, the mean absolute deviation, it's going to give you an idea, are your pieces of data this far away on average from the mean, or this far away on average from the mean, or whatever. It gives you an idea how spread out your data is. How far away is each piece of data from the mean? So I'm going to highlight mean absolute deviation because that's key vocabulary for today, and that's what we're learning how to find. Okay, and we will need to find the mean first. So I'm going to highlight the mean even though we've already done that. The mean or the average. Okay, so let's look at an example. Let's look at finding the mean absolute deviation of 8, the max speed of 8 roller coasters. Okay, so find the mean absolute deviation. I'm just going to abbreviate. Find the mean absolute deviation of max roller coaster speeds. And I'm going to put mph, miles per hour. So they surveyed 8 roller coaster parks. The fastest roller coasters they have, these were the speeds. 58 miles per hour, 88 miles per hour, 40 miles per hour, 60 miles per hour, 72 miles per hour, 66, 80, and 48 miles per hour. So there's our data, max roller coaster speeds. The first thing we need to do is find the mean, or average. So again, that means adding all your data and dividing by how many data pieces you have. 1, 2, 3, 4, 5, 6, 7, 8. So that's the first thing we're going to do. Find the mean is, and again, this is where you got to write carefully, add carefully with your calculator. 58 plus 88 plus 40 plus 60 plus 72 plus 66 plus 80 plus 48. As you're working today, I suggest pointing to the numbers, just keeping track so that you know that's where you are and that's the value that you're working with. And 8 values, 1, 2, 3, 4, 5, 6, 7, 8. And so we're going to total that up. We're going to divide by 8. Again, very carefully on your calculator, you should be typing in 58. I got to tell you, when I did the practice for this, I made more mistakes on this lesson than any other lesson this year. I made tons. You've got to just type in your calculator carefully, and also double check. I highly suggest that you just total everything twice and see if you get the same thing. Crummy looking 8. 58 plus 88 plus 40, all on your calculator. I'm not going to type that in my calculator. I've already done it. I get 512 divided by 8. So the mean, 512 divided by 88, the mean or average speed is 64 miles per hour. So of this data, of the 8 roller coasters, the average speed was 64 miles per hour. Now, after you get the mean, here's what you do to get the mean absolute deviation. So I'm going to write this down right here. Now we're doing what's new today. How do you calculate the mean absolute deviation? What you do is you find the difference between your mean and every data value in your group. So 60, how far away is 58 from 64? How far away is 88 from 64? How far away is 40 from 64? And then you total that and you divide by how many values. It's almost like finding the mean of the mean is the way you can think about it. So I'm gonna let's see. So I'm gonna do this value subtract this value every time. Even though sometimes that's going to give me a negative number, we're talking about distance, so I'm going to take the absolute value. And I'll show you what I mean. So first I'm going to do 64 minus 58. Actually, let me get a different color here so I can show you what I'm doing. 64 is my mean. I'm going to take my mean, 64 minus 58. That's what I'm typing in my calculator, and I'm going to get 6. So the black number is what I'm using. The blue number is just showing how I'm getting it. So then I'm going to take 64 minus 88. So when I type that in my calculator, 64 minus 88 equals, not sure if you can read that, it tells me that I got 24, but it also gives a negative sign. So 64 minus 84 is negative 24, but because we're talking about distance, I'm going to make it a positive 24. I'm just going to do this number minus this number no matter what. If you want to take the greater of the two and subtract, you could do that. You're going to get the same thing. Or if you get a negative number, you're going to use the absolute value of that number, the positive. So next, 64 minus 40. And there I get 24 again. Next, 64 minus 60. And there I get 4. Next, 64 minus 72. And there I get negative 8, but I'm going to take the positive 8 because we're talking about distance. 64 minus 66. And my calculator will tell me negative 2, but I'm going to take a positive 2 because we're talking distance. 64 minus 80. And there I'm going to get negative 16, but again I'm using the positives. And finally, 64 minus 48. And there I am also going to, 64 minus 48, I'm going to get 16. So, all of these are the differences from the mean from each data value. And then I'm going to total that up and also divide this by how many values we have, 8. So carefully typing in all that on your calculator, 6 plus 24 plus 24, all that, you're going to get 100 over 8. And then I'm going to divide 100 divided by 8. And my mean absolute deviation is 12.5 miles per hour. Okay, so what does that mean exactly? What that's telling me is that on average, each data value is 12.5 away from the mean. So it's the deviation from the mean absolute deviation. That's what that means. And once again, this number is telling me that on average, if I look at all these roller coaster speeds, the average away from 64 for all these numbers is 12.5 miles per hour away from the mean. All right, let's do one more example, but before we do that, today's hidden treasure is polygon. Give the definition of a polygon and an example and a non-example of a polygon. All right, so for the next example, we're going to look at two different sets of data and use the mean absolute deviation to describe the differences. So we're going to look at money raised by homerooms in a middle school. And we had grade 6. And the homerooms at this middle school, the grade 6, they raised, one homeroom raised $88, another raised $116, another $94, $108 for another one, $112, and $124. So there's how much money the 6th grade homerooms raised. And we're going to compare that. We're going to find the mean absolute deviation of this data compared to grade 7. How much money the homerooms raised in grade 7. So grade 7, they raised, the homerooms, one raised $144, $91, $97, $122, $128, and $132. So we're going to calculate mean absolute deviation for grade 6 and grade 7 and compare the mean absolute deviations of the two sets of data. So again, first thing, we have to find the mean. So I'm going to do grade 6 mean first. So the grade 6 mean is going to be 88 plus 116 plus 94. I'm adding my data values together and dividing by how many there are. Again, go slow on your calculator. Look at the screen. Make sure, point to each number as you're adding it. 88, 116, 94. You got to be systematic about it. Again, I made more mistakes on this practice than any other lesson I've done all year. And the reason is I mistyped something in my calculator. I lost track of where I was. Maybe I added a number twice or I skipped a number. You've just got to be super, super careful. When I total that up, you get 642 over 6. So the mean, 642 divided by 6. The average for the 6th grade classes was $107. So now for the 6th grade, grade 6 mean absolute deviation. Again, I'm going to use my mean and subtract each data value. 107 minus 88, 107 minus 116, 107 minus 94. I'm not going to write it down like I did this time. I'm just going to show you what the amounts are. If you do it correctly, you would get 19 plus 9, 94, 107 minus 94 gives you 13. 108, how far away is that from 107? That's 1. 107 minus 112 is a negative 5, but again, I'm going to use a positive 5. We're talking distance. 124, or 107 minus 124 is negative 17, but I'm going to use a positive because we're talking distance. Divided by 6. I total all that. 19 plus 9 plus 13 plus 1 plus 5 plus 17 divided by 6. I get 64 over 6. And so the 6th grade mean absolute deviation comes to 1067. So again, this is money, this was money too. So what's that telling me? That on average, each data value in this group is 1067 away from the mean of 107. Okay, now we'll compare grade 7. First thing is calculate the mean. So I'm just going to show that fast. 144 plus 91 plus 97. Adding all my numbers carefully. 128 plus 132 divided by 6. So find the mean. The 7th grade mean or average money raised was $119. Boy, that looks terrible. Let me do that again. 119. $119 was the average. So grade 7 mean absolute deviation. 119 subtract 144, 119 subtract 91, 119 subtract 97. I'm taking the mean and subtracting every data value in the group. And if it gives me a negative number, I'm just going to use the absolute value of that number. So my values for this one would look like this. 25 plus 18 plus, what is that? I can't hardly read my writing. 22 plus 3 plus 9 plus 13. And I'm dividing by 6 because there's 6 values. I total that and I get 100. I divide that by 6 and the 7th grade mean absolute deviation came to $16.67. So what does that tell us? Tells us that on average, you look at the 7th grade data, on average each data value is 1667 away from the mean. So a couple things we could say. We could say that the mean absolute deviation for grade 6 is less than grade 7. this mean absolute deviation was less than the 7th grade mean absolute deviation. So that is one statement that we could make. And another meaning we could say is that the grade 6 data on average is closer to the mean. On average, these values are closer to the mean. Another thing you could say is that the grade 7 data is more spread out. And you can kind of see that just looking in the data. Look at this data. This data is more spread out. We go all the way from 144 to 91. It's more spread out than the 6th grade data. So that's another thing we could say is that the grade 7 data is more spread out. And this number tells us that on average the data is this far away from the mean. So that is today. So the new thing today is the mean absolute deviation, and we'll highlight this one showing exactly how you get that. You take the difference of the mean and each data value in your set, and then you total that and you divide by how many data values you have. So here's another one. Mean absolute deviation. So type carefully on your calculators today. Be slow. Point at numbers so that you're keeping track of where you are. Made a lot of mistakes today, just calculator mistakes. Ooh, excuse me. All right, that does it for lesson 4. You've got one more lesson in chapter 11, so start reviewing your notes and going back and watching any lessons that where you're confused. Lesson 5, and then shortly after that will be your chapter 11 test. I'll see you soon for lesson 5.